Video on reading variables from graphs. So we're going to dive straight in here. So the graphs that I've got here are both linear graphs. They're linear because they've got straight lines. They're the same graph. So we're going to concentrate on the left-hand graph first. So we've got when x is equal to 1, y is equal to, well, we haven't worked that out. So that's what we're going to be doing here. So we want to use our graph to find out what y is when x is equal to 1. Well, we locate x is equal to 1, so our x-axis is our horizontal axis. X is equal to 1 here, so then we read up to the line, and then we read across to y, and we see that y is equal to 3. Okay, so what is y equal to when x is equal to 2? Well, we do the same thing. We find x is equal to 2, which is here. We draw up to the line, and then we draw across to our y-axis and we find that y is equal to 4. Okay then, what about when x is equal to minus 1? Well, we'd find minus 1 on our x-axis. We do the same thing, draw up to the line, and then we draw across to our y-axis. So instead of going left, we go to the right here because we're into the negative numbers. So we draw across and we find that when x is equal to minus 1, y is equal to 1. Okay, and then lastly for the x's, I'm going to ask, what is y equal to when x is equal to minus 2? Well, we find x is equal to minus 2 on our x-axis, which is here. So we would draw up to the line normally. We can't do that because the line actually cuts through the x-axis. So because it cuts through the x-axis, the line isn't moving up or down there. So we say that when when x is equal to minus 2, y is equal to 0. Like that. Then we could write these as coordinates. So we remember that the left-hand coordinate is our x-axis and the right-hand coordinate is our y. So we'd have 1, 3 for the first coordinate. Then we'd have 2, 4 for that coordinate. Then we'd have minus 1, 1 for that coordinate. And then finally we'd have minus 2, 0 for this coordinate. Okay then. So now we're going to focus on the graph on the right. It's the same graph as this. Instead, we're just going to reverse the process. So rather than finding y values from x, we're going to find the x values from y. So I would like us to find, firstly, what is x equal to when y is equal to 1? Well, we'd find y is equal to 1 on our graph. So on the y-axis we find 1. We draw across to the line, and then we draw down to our x-axis, and we find that x is equal to minus 1 there. When y is equal to 2, well, we'd find 2 on our y-axis, which is here, and we haven't moved the left or right there, so it's the same situation as we had at the bottom here, so x is equal to 0. And then finally, for y is equal to minus 2, well, we'd find minus 2 on our y-axis, which is down here. We draw across to the line, which is there, and then we'd have to draw up to our x-axis from the line, and we find that x is equal to minus 4 there. If we wanted to write these as coordinates, we have to remember that our left-hand coordinate is the x, so this time we'd have minus 1, 1. So our left-hand coordinate is the x, so we minus 1, and then the y-coordinate, which is y. So for this one, it would be 0, 2. And then the bottom one is minus 4, minus 2, like so. We have a slightly different graph. This is called a quadratic graph. So it's kind of like a smiley face, that is what people call it sometimes. Okay, so for our quadratic graph, we'll start with the x's. So we'll have when x is equal to 1 firstly, what is y equal to? Well, we do the same thing as we did for the linear graphs. We'd find 1 on our x-axis, which is here. We draw up to the graph, and then across to our y-axis, so we find that y is equal to 1. Okay, what about when x is equal to 3? Well, we find 3 on our x-axis, which is here. We draw up to our line, we draw across to our y-axis, and we find that y is equal to 9. Okay, what about x is equal to 0? Well, we find 0 on our x-axis, which is here, and the graph, or the line, isn't moving up or down there, so y is also equal to 0. Okay, so what about negative values of x? Well, when x is equal to -1, again we find -1, draw up to our line, and then across to our y-axis we find that y is also equal to 1. And then finally we'll look at x is equal to -2. So when x is equal to -2, what is y equal to? Well, we find -2 on our x-axis, draw up to the line, then we draw across, and we find that y is equal to 4. Okay then, so as we know, we can reverse this process, and we can use y values to find x. Okay then. So I'm just going to pause the video here and change the graph so it's not got any drawings on, so we can start again. X values from specific y values. So when y is equal to 9, so when y equals 9, what is x equal to? Well, we can draw our line across to the curve, and then we can go down to our x-axis, and we find that x is equal to 3. However, we can also draw a line this way to our curve, and go down to our x-axis, and find out that x is also equal to -3, so x is equal to 3 or -3. Okay, so let's try another number. So how about when y is equal to 4? Well, we find 4 on our y-axis, we draw across to the curve, down to our x-axis, so we find that x there is equal to 2. But again, we can go left to our curve, so here and then down, and we find that it can be also equal to -2. Okay, and then we'll try one more. So when y is equal to 1, what is x equal to? Well, we find 1 on our y-axis, draw across, we find that x is equal to 1. Or we can go this way, so left and then down, or it can be equal to -1. Okay, so then we ask, well, why is this? Well, this curve, in fact, is the graph of y is equal to x squared. So if we have our y value, so let's take the first example, so when y was 9. Well, if we've got y was 9, so then 9 is equal to x squared. Well, if we want to find out what x is, we just square root both sides, so we get 9, which is equal to, sorry, the square root of 9, which is equal to x. Well, the square root of 9 can be both positive and negative, because we could have x is equal to 3, and x is equal to -3. Well, why is that? Well, squared means you times the thing by itself. So for x equal to 3, we've got 3 times 3, and we're happy that that is 9. oops, so 3 times 3, which is equal to 9. But we also have minus 3 times minus 3. And minus 3 times minus 3 is also 9, because two negatives make a positive. So that was a look at reading values from a quadratic. We have a slightly different type of graph. We have what is called a piecewise linear graph. Why is it called a piecewise linear graph? Well, it's connected of pieces of linear graphs. So we can see a linear means that we have straight lines. So we've got a straight line here, and then connected to a straight line, connected to another straight line. So that's why it's called piecewise. Okay, so we can read this in exactly the same way. So if we want to find out what y is equal to when x is equal to 4, well, we find 4, so 1, 2, 3, 4, read up to our line, read across to y, and we'd find that y is 1, 2, 3, 4, so y is equal to 4. Okay, if we want to find out what y is equal to when x is equal to 7, well, we find 7, so 5, 6, 7, we'd read up to our line, and then we read it across to our y-axis, so we'd find that y is equal to 5. And I'm just going to take that line away actually, so then we find that y is equal to 5. And then finally, if we want to find out what y is equal to when x is equal to 12, well, if we've got x is equal to 12 here, we would find 12, so 11, 12, so it's here, draw up to our line, and then draw across to our y-axis. It's a very badly drawn line, but 5, 6, 7, so y is equal to 7. Okay. So as we know, we can reverse the process. We could take our y values and find out what x is. However, instead here, I am going to pose the question. So I'm just going to type this out actually. When y is equal to 5, what is x equal to? So when y is equal to 5, what is x equal to? Well, we'd find y is equal to 5 on our graph. So I just need to put just add another layer. So when y is equal to 5, what is x equal to? Well, we find y is equal to 5, we draw across to our line, and we can see that the graph there, so if we draw to our line and then down to x, well, we see that x is equal to, so x is equal to 5, but we could also go to this point and draw down, so we'd have x is equal to 6 as well. We could also draw across to this part and find that x is equal to 7. And we could also go to this part here where x is equal to 8. So there are in fact 4 values of x when y is equal to 5. So that's a slight difference with a piecewise linear graph, that we can have flat sections. So we could apply this to a a distance time graph, because they tend to have curves that look like this or things like that, which you may have seen. So if this is just a quick sketch of a distance time, so we'd have distance up here, and we'd have time across the bottom, and essentially a distance time graph is a piecewise linear graph, in this case anyway, because we've got a series of straight lines which are connected. So we can apply what we've learned here to a graph like this. We're not going to do that in the video, however, but I just wanted to make it clear that you could. This type of graph is called an exponential graph. So the common feature of an exponential graph is that it has this J-curve. So we can do exactly the same as we have done before. We can read off specific x values and read to the line and then to the y-axis and find y values. So if we want the value of y when x is equal to 1, well, we'd find 1. We read up to our line, we read across, and we find that y is equal to 2. Okay, so we'll try another. When x is equal to 3, well, we find 3. Well, 2 is there, so 3 will be here. We read up to the line, and then we read across, and we find that y is equal to 8. Okay. What about when x is 1.5? How would we deal with that? Well, we find 1.5 and we're going to have to estimate here. So when we're reading values that aren't exact, we're going to have to do some sort of estimation. So we'd find 1.5. Well, we said that 1 was there, so 1.5 is roughly in there. So we draw up to our line. Then we draw across. So it's just under 3, so we'll call it 3.9. So y is equal to 3.9. Okay. What about when x is 0? Well, when x is 0, we find that on our x-axis. We go here, read up to the line, and that's at y is equal to 1. So y is equal to 1. So we know from all the work we've done previously in the video that we can reverse this process. We could take a y value and we can read to the line. So if we took when y is equal to 4, we can find x. So when y is equal to 4, well, we'd read across to our line, then down, and we find that that x is equal to 2. Okay. What about when y is equal to 0? And this is a very special property of the exponential graph. So when y is equal to 0, well, that means we're here. So we're not going up and we're not going down, we're at this line. So ordinarily what we would do is we would read across to our line and we keep reading. Now it looks there like our graph touches the x-axis, but it actually doesn't. It actually doesn't touch the x-axis. It gets very, very close to the x-axis but doesn't touch it. And the word for that is an asymptote. So there's an asymptote to this graph. So it gets very close to this x-axis but will never touch it. So we could have all the way down to minus 1,000, minus 10,000, minus 1,000,000. It would keep going and keep going. So minus infinity, really. So it's a very special property of our exponential graph and something that you would need to remember. Final graph that we will look at, and this is called a reciprocal graph. So we can do exactly the same as we have. If we want to find the value of y when x is equal to 1, well, what we would do is we'd read from 1 on the x-axis up to our line and then across, and we would find that y is equal to 1. Okay, what about when x is equal to 3? Well, we'd read up to our line. Again, we're going to have to estimate slightly here. So we would read across, and that looks like when x is equal to 3, it looks like y is going to be, we'll call it 0.2. A very small value of y anyway. Okay, and what you might notice is that we have a J-curve really in this graph, and it gets very, very close to this x-axis but doesn't touch it. So it's like our exponential. So if we go all the way to x is equal to 10, it still y wouldn't be 0. Y would be small, very small. Okay, so what about the left-hand side of the graph? Well, when x is equal to minus 1, what is y equal to? Well, we find x equal to minus 1 there, we'd read down, read across, and we'd find that y is equal to minus 1 there. Okay, what about when x is equal to minus 3? Well, we'd find minus 3, we read across, so it looks like it's going to be minus 0.2. So as you can see, we're finding that these values here, so these values that I've just drawn in this box here, have the same numbers as these values in this box here. They're just minus, and that's to do with this property of the reciprocal graph. So as you can see, we've got the same curve, just in different quadrants of the graph. We've got the same curve, just in different quadrants of the graph. Okay then, so when x is equal to 0, what is y equal to? When x is equal to 0, that means that we're not moving left or right, so we're here. So if we were going to find our y values, well, we would have to draw onto the line until we saw the blue line. So like this. But as you can see, our blue line doesn't touch the y-axis at any point. And it's like the idea we had with the exponential curve. It will get very, very, very close to the y-axis, but it will never touch it. It will never cross it. So that means that when x is equal to 0, well, we can't find y values. So there are none. So when x is equal to 0, so I'll just write this in red. When x is equal to 0, there are no y values. So there are no y values. And that's because this graph, like the exponential graph, is asymptotic. So it will get very close to the y-axis, but it will never touch it. So there are no y values when x is equal to 0. So we would say there that the curve is undefined when x is equal to 0. So that's an interesting property of the reciprocal graph. So we've ran through linear, quadratic, linear piecewise graphs, exponential and reciprocal graphs. And we've seen how we can take x values and find y values, take y values and find x values. And we've seen that these graphs all have different properties that mean we get different values for different graphs. So I hope you enjoyed the video. And I would run back through it and have a go at trying to find some values yourself. That would be a useful exercise. So thank you for watching.